Today's GDC talk is on solving puzzle design given by Jolie Menzel. It'll be presented by Haley Fairbanks and myself, Jacquia Powell. You might be asking yourself, why puzzles? With puzzles, you get to combine tons of different concepts in game design to create a single unit of a game. In puzzles, they are primarily made up of 5 different components, which are your mechanics, level design, narrative, difficulty balancing, and progression. Together, these components will make a great experience for a player. So what's a puzzle? A puzzle is a game with a dominant strategy. It will have many paths, but one is clearer than the rest. Puzzles are typically played to find a solution, while games are played to win. They are a challenge, but not a competitive challenge, and it's meant to make a player stop and think about their choices in order to progress to the next stage. So what makes a puzzle good? It's definitely fun, but that fun comes from a challenge. The challenge makes a player feel a sense of trust and respect from the designer. It should invite you, the player, to find a solution, not be handed one. Basically, it's also another way of saying that it should make the player think. The solution should also be attainable. Once again, the answer wasn't given to you. The player should feel a sense of accomplishment once they complete the puzzle themselves. The example I use is from a game called I Love Hue 2. You basically have to match the next hue in order to get the gradient right. It's a great example of a puzzle being fun because of a challenge. Because for those that don't know, colors can appear to be another shade or hue when placed next to a certain color. So the answer may look correct, but once you move that piece, you realize it isn't the color you expected it to be. Once you place all the colors in its correct spot, you do get that sense of accomplishment by seeing the completed gradient. Precision of emotion, a new kind of fun approach, is a theory from Aaron Hoffman's GDC talk in 2015. It's basically the search of knowledge is an emotional journey in which a player achieves mastery of a situation, concept, or puzzle, which is where Sophia comes into play. Sophia is the emotion of finding mastery. There is also an emotional journey in which a player goes on to master a concept or puzzle. This is known as the Sophia loop. The Sophia loop includes fear, which is created by an absence of skill, surprise, which can lead to curiosity, speculation, stress, discovery, and insight, and happiness, which is the equivalent to mastery. In the example below is of a level in Portal. The player must get to the other side, but can't. The player may start to panic because you can't seem to portal over to the other side of the room by placing a portal on the wall. Then, as you look over the ledge, you find a platform you can get down to and place a portal on the floor of that platform that then leads to the other side of the room where the exit portal is. In this example, you have your fear. You can't progress to the other side. Therefore, you can't progress to the next level. Then you have your surprise of finding a platform when you look over the edge of the higher platform and seeing the exit when the portal is placed. And finally, you're feeling a sense of accomplishment because you've now cleared your level. The example also ties in with puzzle mysteries, as you normally have to search and look for clues in the surrounding areas to be able to find insight on what to do next. The goal of a puzzle is typically to find a key that goes into a lock. There are 2 main elements of a puzzle. The first is mechanics, which can be further split into verbs homogeneous and heterogeneous. These are the mechanics a player can do and use in a level. The second element is theme, which is split between narrative and presentation. The theme is something that isn't straightforward, but is always consistent. This contributes to giving context to the puzzles and what the player can do. The player can find relationships between different things and different information that they learn from the world. Similar to Link's bombable rocks, the design can be disguised in some way that still tells a story. A homogeneous mechanic is system-based. This means that it has a specific problem that the player can anticipate. It can also be adjusted while playing the game. An example of this is the grappling hook in bombable rocks in the Legend of Zelda series, particularly in Wind Waker. The grappling arm is designed to look different on each island depending on the environment. Once the mechanic is introduced, the player knows that no matter where they are in the game, if they point the grappling hook towards a grappling arm, it'll most likely attach and allow Link to get past an obstacle. The same goes for the bombable rocks. Their design is different compared to surrounding rocks. There's also almost always a bomb plant next to them, guiding the player to use one on the rock. Most of us are probably using these kind of elements in our dungeons. A heterogeneous mechanic is context-based. This means that they should examine surroundings and sometimes the story to get more information. This usually applies to classic adventure games. You must typically use an interactable object on another as the results are unpredictable. This is because the mechanic is meant to be somewhat random but will still help to progress through the level. Sam and Max is based on the comics, and if you're familiar with the comics, then you would know that Max is a violent character. In this example, the cat has eaten a piece of evidence. To help Sam, you must use Max to get it back. Once Max has been selected, he will then rip the evidence from the cat's stomach. Based on the narrative of the comic, if the player has to do something violent, they know to use Max. For this class, we will rarely have something like this in our dungeon since this kind of element is unpredictable, and most of us probably didn't include a narrative to draw from. Difficulty. This is the secret element to making a good puzzle, but it's also the hardest thing to do. To help with the process, we have difficulty dials. There are 3 steps for difficulty, which are the steps it takes to solve each puzzle, revealing new information, and new applications. The first step will be to tweak a puzzle to make it easier or harder, which just refers to how many steps it takes to solve a puzzle. You should also consider how much time passes before the player gets feedback. This can be positive or negative. The gap of time between clues can also make puzzles easier or harder. The puzzle should get progressively harder as new obstacles show up, which is just to say that puzzles should always gradually be getting harder. The second step is a new mechanic or information revealed. This also refers to what you can and cannot do. The mechanics should be slowly added on to previously taught mechanics. This keeps the player learning on how to beat future levels. The third step is a new application of existing mechanics or information. For this, you should find a key, solution, or information in a new way than you're used to. This is another reference to taking the time to stop and think about your options. Though this is only half of the puzzle, the other half is difficulty considerations. The first thing you should consider is your intended audience. You need to ask yourself, why am I making this game and why are there puzzles? If you have a narrative-focused game, you don't want the player stuck, so you don't want the puzzles to be too hard. You want your game to be as accessible as possible. If you have a challenge-focused game, the difficulty will be much harder here as it's intended to be a challenge and your audiences are also expecting it to be. You should also consider the location of a puzzle in progress. So consider where it's going to be experienced and how, whether that's in level or in the game. I will now hand off this presentation to Haley.
I'm going to start off with rational puzzle design for progression of your puzzles that you can use. Rational design in general is introducing concepts in an orderly fashion and preserve macro flow. Macro flow is looking at your game from top to bottom, understanding everything that you are making for your game, knowing where it goes into your game and when or where the player will experience it. So you'll take your game, breaking it into a piece of your game, which would be a act, and then finding the level it's in, and then you'll find your puzzle. No matter what type of puzzle, you should look at it from a bigger picture. Why this puzzle is here and what is it teaching the player. So she uses Portal as an example. In the beginning, the player is learning how to use the portal gun. These steps are very few, and by the end of this act, the player is fairly used to the mechanic of portals. After experiencing a difficult puzzle, you would give what is called a breather puzzle to the player. This is lower in difficulty, and once the player completes this small breather puzzle, it gives the player confidence after completing such a difficult puzzle beforehand. The complicated puzzles and mechanics are taught earlier on in multiple times to get the player ready up until this point. The game gives an example earlier. It shows the portal on the wall or on the floor. This means that the portals can be placed on the walls and the floors, and the player uses this mechanic that they've seen visually to solve a puzzle later on in the game. So when you're building a puzzle, you should know the player's goal. If you don't know the player's goal, then the player won't know. Message what your key is, what your lock is, and message the steps to that goal. So you'll want to give the player feedback, reward and encourage the player when they are on the right track, and communicate with them when they reach a dead end. You should be kind to your player. Repetition isn't fun, and check your skill checks. You can also integrate stories into the puzzle and get inspiration from your story as well when creating puzzles. So as an example, when building puzzles, in The Walking Dead, they gave you symbols or letters on the ground or in the environment. They have you inspect a broken flashlight on the ground earlier on, and then once you inspect this first object, next you'll see an icon or a symbol show up that you can inspect this glass. And following these pieces leads you to an alleyway, which there is an X on the wall that you can find. The X isn't seen on the wall unless you inspect these other pieces beforehand. This also preps the player that these things are connected to each other. If the player has to brute force a puzzle, it's frustrating to them. They may not see the puzzle in it and they might skip it. So, troubleshooting. You want to user test. Do it as much as you can. Capture as much of your tester's thinking process as possible. Note where the player gets stuck. Look at your skill checks to examine why the player is getting stuck at this location. When the player says, "Was this too easy?" did you give the player a chance to solve it themselves? Did you tell them how to solve it, or was it already taught previously? Was it just a lock and key? Was there not enough steps and it was very simplistic? No variation in verbs or applications? If they say that the puzzle was too hard, is the information given to solve the puzzle? How long ago was this information given, and can it be reaccessible? Is the goal to the player clear? You can use level layout and visuals to make the path clear. Check your dials. Are there too many steps? Is a new mechanic not being taught well? Or a mechanic is being used in a new way that is unintuitive? It's very common that designers play their games so many times that it seems easy to the designer, but maybe not the player. It's great to make new applications and mechanics, but if it's not being taught well or wasn't tutorialized, not intuitive, the player will have a hard time solving the puzzle. And then some things to remember. A good puzzle challenges the player without hand-holding or being unfair to the player. It's fun for them, but not for the designer. Puzzles combine a game's theme and mechanics and rely on the consistency of each to make sense. You should look at your puzzle in context of the game as a whole to judge its difficulty, and watch others play your puzzle to check for assumptions you may have made. And then lastly, for our question, what are some ways that you can improve your puzzles after listening to this discussion? In what ways have you already implemented some of these into your dungeon? And were they successful based on the initial peer review, or did players struggle to understand that goal? This is the end of our Solving Puzzle Design GDC Talk presentation. Thank you for listening, and we will hear from you guys next class.